Hi, my name is Jenny Levy. I'm the Vice President of Corporate Social Responsibility here at Hypertherm. We are 1,400 employees worldwide who together own this company. We have been designing and manufacturing advanced industrial cutting systems for 50 years, a heritage we're all very proud of. You can find our products hard at work across the globe, helping to build everything from bridges and skyscrapers to snowmobiles and tractors. So come on in and take a look at the new world of engineering and manufacturing. We think you'll be amazed.
Hypertherm manufactures plasma, water jet, and laser cutting systems, along with controllers and software solutions. Here in our New Hampshire facility, we make two types of plasma equipment. PowerMax, which is used for smaller cutting applications like auto repair and some very cool metal art. And mechanized systems, used for cutting larger sheets of metal for all kinds of building projects. And with both, it's plasma that gets the job done.
Plasma is about 20,000 degrees, or similar to the temperature of the sun. It's the high temperature of the plasma itself that's really the magic. And that high temperature allows our machines to cut steel very quickly and very cleanly.
Before our products can be built, every part has to be determined and designed, from valves to sheet metal to circuit boards. And making sure our products perform the way they should requires a lot of testing.
Testing is an important part of the work that we do. You know, you can design one product, but you don't really know if it's going to work on all the continents in the hottest and the coldest areas.
In this lab, engineers are testing to see how well the products perform in different environments, from extreme heat to extreme cold. Engineers also use new technologies, like 3D printing in the design process.
3D printing, it's different than traditional manufacturing where you take maybe a piece of bar stock and you scrape away the material. The 3D printing, you start with nothing and you add. The real exciting part of the 3D printing is you can create shapes that you cannot create in any other way. We have used it to make products or prototypes that we're just testing out to speed up our learning.
This is our components manufacturing area. We manufacture electrodes here, which go into all of our systems.
We have many computer-controlled lathe machines. Operators set up and program the machines to precision cut each of the copper electrodes, and we crank out thousands of them a day. 12-foot-long pieces of bar stock are loaded into the machine, one piece at a time.
It goes in as a piece of bar stock and it comes out as a finished product based on how we tell these machines to make these parts. It's amazing how fast they can move. Right around every 17 seconds we have an electrode that's made. When the parts come down to the end of the conveyor, Bazooka Joe grabs them and puts them in the trays for us. One of the unique things about our machines here is that we actually use canola oil to keep all of our tooling cooled when we're machining these components. Canola oil is a lot safer for our associates than using a petroleum-based coolant, and it's a lot safer in the environment.
We also collect all the scrap from machining and place it in bins for recycling. When you're dealing with parts that have to be accurate within 3/1000ths of an inch, that's thinner than a human hair. You need some killer technology to measure that. This instrument uses a little ruby on the tip of a probe to touch specific points on the electrode to check the measurements.
The comparator is based off of a shadow system. We put our parts in front of a light, it creates a shadow, and with that shadow we're able to measure features on our parts that normally can't be measured otherwise. So I just measured that feature and it came out awesome.
When parts are completed, they go to the laser for marking.
So our laser at this point is going to etch the part number on these specific parts at the systems that these are specifically made for.
This is one of Hypertherm's robotic cells, and it makes the shields that go on our PowerMax products. So imagine you needed to pick up a very small part and move it from one place to another, and then move it again. Thousands of times a day, that would injure your wrist or your elbow or your shoulder. So robots are able to do that much better. By using our robots Hans and Becky, we're able to make thousands of parts a day, and the robot can operate with no people overnight or over the weekend when people don't want to work. Associates have had a really positive reaction to working with Becky and Hans. The robots end up doing a lot of the more boring and repetitive tasks, and that leaves the people to do the programming of the machine and to really work alongside the robot.
This is where all of the plasma products are assembled and tested. You can see some great teamwork here.
We build as a team not only because we want to, but it's part of the culture that we have. So we go to lunches as a team and we take breaks as a team. You can't take individual breaks on this specific assembly line because you need a full team to run efficiently.
Every product is built in steps, and each assembler has an assigned task.
We build 60 units a shift, and that's in 8 hours. So each assembler has 7 minutes to complete their task before they pass it on to the next assembler. The green thumb indicates that this assembler is done with their job task. They go through step-by-step visual instructions on how to build the system, and then when they are done with their job, they'll hit the green thumb. If they don't hit the green thumb, the person on the next station can't pull the work.
Assemblers also scan each part as they install it to ensure 100% accuracy. When assembly is completed, each product is tested, packed up, and shipped off to the customer to be used all around the world. Beyond their job assignments, associates also participate in various special projects to increase efficiency and reduce waste, including playing with homemade Legos.
One of the things we do is called a 3P event. It stands for Production, Preparation, Process. So we brainstorm a whole lot of different ideas about how to best lay out our factory. So we've made to scale 3D printed pieces of every machine, every desk, every beam, every stairwell in the factory, and then that way we can rearrange it and really bring to life those brainstorms, and we can see which of those have the best effect on our efficiency. So it's fun to work as a team and get input from people from across the organization and use this model to kind of create your perfect vision of the perfect, lean, efficient manufacturing facility.
Well, we hope you have a better idea now of what we do here at Hypertherm and just how exciting the world of manufacturing and engineering can be.